প্রিয় শিক্ষার্থীবৃন্দ, আসসালামু আলাইকুম। মাস্টার্স ফাইনাল ইয়ার শিক্ষার্থীদের স্বাগত জানিয়ে আজকের ক্লাস শুরু করছি। আজকে আমি তোমাদের স্লো রিনল্ডস নাম্বার ফ্লো এর দ্বিতীয় লেকচারে স্বাগত জানিয়ে শুরু করছি। আজকে আমি তোমাদের একটা প্রবলেম নিয়ে আলোচনা করবো। চলো আমরা প্রবলেমটা শুরু করি। প্রবলেমটি হচ্ছে শো দ্যাট the solution for velocity and pressure in the case of very slow motion past a sphere in an incompressible viscous fluid is given by number 1 u is equal to u naught 3a x square by 4r cube a square by r square minus 1 plus 1 minus a by 4r into 3 plus a square by r square. Number 2, v is equal to u naught 3axy by 4r cube a square by r square minus 1. And number 3, w is equal to u naught 3a xyz by 4r cube into a square by r square minus 1. তাহলে প্রবলেমটা হচ্ছে show that the solution for velocity and pressure in the case of very slow motion past a sphere in an incompressible viscous fluid is given by u is equal to u naught 3x square by 4r cube a square by r square minus 1 plus 1 minus a by 4r into 3 plus a square by r square. Number 2, velocity v is equal to u naught 3axy by 4r cube a square by r square minus 1 and w is equal to u naught 3xyz by 4r cube a square by r square minus 1. তাহলে এটা হচ্ছে আমাদের প্রবলেম। এখন আমরা প্রবলেমটা সলভ করব। তাহলে সলিউশন consider a solid sphere of radius capital R. তাহলে আমরা একটা সলিড স্ফিয়ার কনসিডার করতেছি যার রেডিয়াস হচ্ছে ক্যাপিটাল R is held at its center at the origin in a uniform stream at viscous incompressible liquid having undistributed velocity u naught and pressure p naught। তাহলে আমরা ধরে নিলাম একটা সলিড স্ফিয়ার ধরে নিলাম যার রেডিয়াস হচ্ছে r is held at its center at the origin in a uniform stream or viscous incompressible fluid liquid having undistributed velocity u naught and pressure p naught। তাহলে Navier-Stokes equation for incompressible viscous fluid del q by del t plus q dot nebula dot q is equal to body force minus 1 by rho pressure gradient plus nu nebula square q। As a first approximation, Stokes neglected the convective terms. This term is called convective term। convective term neglect করার কারণ কি? This is a non-linear term. Since the velocity is very small, so the product of the velocity is also very small compared to 0. Let the flow be steady. Steady means del q by del t is equal to 0, and let there be no body force. That means F is equal to also 0. Then Navier-Stokes equation and the continuity equation reduce respectively 1 by rho nebula p is equal to nu nebula square q, and equation of continuity is equal to 0 where q is equal to UVW. The boundary conditions are Q is equal to 0 at r is equal to capital R, q is equal to u naught 0 0 as r tends to infinity. This is equation number A, this is equation number B. তাহলে আমরা convective term neglect করলাম because the product of velocity, since the velocity is very small, so the product of the velocity also small, and the flow be steady. Steady means del q by del t is equal to 0, and there is no external body force, that means F also 0. So we can write the Navier-Stokes equation in this form: 1 by rho nabla P is equal to nu nabla square Q, and equation of continuity is equal to nabla dot Q is equal to 0 for Q is equal to UV W. The boundary conditions are Q is equal to 0 at R is equal to R, and Q is equal to U naught 0 0 at R tends to infinity. In Cartesian coordinates, del p by del x is equal to mu del square nabla square u, del p by del y is equal to mu nabla square v, del p by del z is equal to mu nabla square omega. This is number 1, 2 and 3. If we draw the figure, we get the this is the figure. This is flow, uniform flow, U naught center, y-axis, x-axis, pressure P1, P2, radius is capital R, and the angle between the smaller radius R is theta. This is the figure of the spherical sphere where radius is R, flow pattern is uniform, pressure gradient, pressure is P1 and P2, these 2 points, the pressure is P1 and P2, x-axis R is equal to theta. And the equation of continuity, and the equation of continuity, del u by del x plus del v by del y plus del w by del z is equal to 0, with corresponding boundary conditions. U is equal to V is equal to W is equal to 0 at R is equal to capital R, U is equal to U naught V is equal to W is equal to 0 at P is equal to P naught at as R tends to infinity. Now differentiating 1, 2, 3 with respect to x, y, z, we get now differentiating with respect to x, y, z in 1, 2 and 3, we get del square p by del x square plus del square p by del y square plus del square p by del z square is equal to mu into del square by del x square del u by del x del v by del y del w by del z plus del square by del y square del u by del x plus del v by del y plus del w by del z plus del square by del z square del u by del x del v by del y del w by del z, this which is equal to del square p by del x square plus del square p by del y square plus del square p by del z square is equal to 0, because del u by del x plus del v by del y plus del w by del z is equal to 0, which implies that nabla square p is equal to, which satisfies the Laplace equation and is harmonic function. Since the pressure satisfies the Laplace equation, so we can say that this is a harmonic function. And let the pressure since the pressure is a harmonic function, let the pressure be P is equal to P naught minus x by r cube in this form, where A is a constant and r is equal to root over x square plus y square plus z square. any function, then del f by del x is equal to del f by del r into del r by del x, which is equal to del f by del r into half x square plus y square plus z square to the power minus half into 2x, which is equal to x by r into del f by del r. Similarly, we can write del f by del y is equal to y by r into del f by del r, and del f by del z is equal to z by r into del f by del r. Which implies that del by del x is equal to x by r del by del r, del by del y is equal to y by r del by del r, and del by del z is equal to z by r into del by del r. Now del p by del x is equal to 0 minus del by del x into x by r cube. From this value p is equal to p naught minus x by r cube. Since p naught is a constant, so del p by del x with respect to x, differentiating p with respect to x, we get p naught is 0, del by del x is equal to this, which is equal to minus a by r cube plus 3x by r to the power 4 into del r by del x. This is equal to minus a by r cube plus 3a x square into r to the power 5. Putting the value of del by del x, where del by del x is equal to x by r into del by del r. Putting the value of del by del x, we get this value, r cancel, del by del r so we get del p by del x is equal to a into 3x square by r to the power 5 minus 1 by r cube. Similarly, del p by del y is equal to a into 3xy by r to the power 5 and del p by del z is equal to a into 3xz by r to the power 5. Since del p by del x is equal to mu into nebula square u, which implies that nebula square u is equal to a by mu into 3x square by r to the power 5 minus 1 by r cube. This is equation number 4. Similarly, nebula square v is equal to 3a by mu xy by r5. This is number 5. Nebula square w is equal to 3a by mu xz by r to the power 5. This is number 6. So we get the value nebula square u is equal to this, nebula square v is equal to this, and nebula square w is equal to this. From symmetry consideration, after integration, solution of 4 to 6 becomes u is equal to minus a by 2 mu x square by r cube plus u naught plus d by r plus c into 3x square by r to the power 5 minus 1 by r cube. This is number 7. V is equal to minus a by 2 mu xy by r cube plus 3d xy by r5. Number 8. And w is equal to minus a by 2 mu xz by r cube plus 3d xz by r to the power 5, where b, c, d are constant to be determined. Now, velocity components u, v, w must satisfies the equation of continuity. So you can write del u by del x plus del v by del y plus del w by del z is equal to minus a by 2 mu plus b into x by r cube plus 9c minus d into x by r to the power 5 minus 15 into c minus d into x cube by r to the power 7. So we can write, since the equation of continuity is equal to 0, we can write minus a by 2 mu plus b x by r cube plus 9 c minus d into x by r5 minus 15 c minus d into x cube by r7. Now equating the coefficient of like terms, we get minus a by 2 mu plus b is equal to 0, implies that b is equal to minus a by 2 mu, and c minus d is equal to 0, implies that c is equal to d. Now applying the boundary conditions, u is equal to v is equal to w is equal to 0 at r is equal to capital R, we get 0 is equal to axy by 3 mu r cube minus plus 3 dxy by r5, and 0 is equal to minus ax z by 3 mu r cube plus 3 dx z by r5. Further, calculating both of this equation, we get 6 d is equal to a r square by 6 mu, which is equal to c. Now putting the value of b and c in 7 and putting u is equal to 0 at r is equal to r, we get 0 is equal to minus ax square by 2 mu r cube plus u naught minus a by 2 mu r plus a r square by 6 mu 3x square by r to the power 5 minus 1 by r cube. Putting these values in b and c in 5, we get this equation. By calculating this equation, we get a is equal to 3 by 2 mu r u naught, so b is equal to minus 3 by r u naught. Thus, the complete solution of the equation A subject to the boundary conditions B are obtained as U is equal to U naught 3R x square by R cube R square by R square minus 1 plus R by 4R into 3 plus R square by R square, and V is equal to 3 by 4 U naught into R xy by R cube R square by R square minus 1, and W is equal to 3 by 4 U naught R xz by R cube R square by R square minus 1, and pressure distribution P is equal to P naught minus 3 mu U naught Rx by 2 R cube. Finally, we get the solution of this velocity distribution. U is equal to this, V is equal to this, and W is equal to this. The above equation, the above solutions are known as Stokes solution. For small Reynolds number flow or very slow motion. তাহলে প্রিয় শিক্ষার্থীবৃন্দ, আজকে আমরা যে প্রবলেমটি আলোচনা করলাম এবং পাশাপাশি সলভ করলাম, প্রবলেমটি একটু ক্যালকুলেটিভ টাইপের এবং লেন্থি। তোমাদের বুঝে বুঝে ক্যালকুলেশনগুলো করতে হবে। আমি অনেকটা শর্টকাটভাবে দেখিয়েছি, কারণ ক্যালকুলেশনটা অনেক লেন্থি হয়ে যায়, লেকচারটা অনেক বড় হয়ে যায়। আশা করি তোমরা ভেঙে ভেঙে করলে বুঝতে পারবে এবং কোনো ধরনের সমস্যা হলে আমাকে জানাবে। সেই প্রত্যাশা ব্যক্ত করে আজ এখানে শেষ করছি। সবাই ভালো থেকো। আল্লাহ হাফেজ।